네. 오는 대로.
안 보고 하시는데요?
잠시만요.
Today I'm speaking about vector-based TinyML sensor modeling, and sorry for my poor pronunciation in advance. Start with why TinyML is emulator-based approach. This table shows development goals used for mainly for TinyML applications, and table for the side shows ML mobile and tiny category benchmarks, and I converted these models for separable light format and C array format used for separable light for microcontroller framework. And right side graph shows C converted benchmarks model and compared to each ball's flash size. And as you can see, almost model cannot be flash constraint of mobile category, and only few balls can meet their flash size for each tiny categories models. And currently, several emulators are proposed for MCU development. This emulator has a lack of consideration for top-level I/O. In case of TinyML application, TinyML aims for processing overflow for machine learning. So it covers from sensor measurement and receive sensor data flow through base protocol and processing data and inference. So it needs to consider high-level I/O between sensor interface and MCU device. So bottom graph shows how much ratio occupied for sensor interface. This shows for almost model by over than 50%, and only this model shows less than 50, but as you can see, almost model occupies over than 50% for sensor interface among each execution type. It shows I plot this graph. X-axis is make operation count and y-axis is execution type. Models as smaller size of model shows ratio of sensor interface execution time is much higher than larger size of model. So in case of TinyML, smaller size of model for TinyML is much dominant for sensor interface execution time. So we need to consider sensor interface overhead during the development of model. This shows the overview structure of my proposed emulator approach. The left side is conventional emulator approach, and this shows each sensor model, and it has a variety of fidelity. Usually we need to develop match each callbacks to manually. However, my proposed approach can use abstracted sensor model, which is discussed in next slide. So I model sensor as a hierarchical abstract level, and this layer called as a protocol translator input protocol, which is described as a state machine diagram, and it can convert the diagram from diagram to input back. Yes, it's the role of protocol translator. And this shows some cases for hierarchical sensor modeling. From for high level extraction and low level extraction, we can omit some unnecessary stage that developer do not want to see in the emulation scope. So we can, as the developer, as on demand of developer's fidelity, the emulator can skip each stage of MCU received sensor data from sensor. For example, interface protocol can be omitted, or MCU access sensor data on special function register map. Register map. So this shows how protocol translate work in detail. It use input as a state function, state machine diagram as a user as an input, and sequencer in protocol translator configure matching from function register and callbacks for each special function register, and then each callbacks has their own state machine in callbacks. As a fidelity determined in FSM diagram, it utilizes only selected state in their callbacks, and each state can communicate with sensor model API in right side. So this is an example of FSM one-state machine diagram which used as input for protocol translator. This case shows two case I2C interface and SP interface. The result shows this sensor modeling approach can decrease the unwanted emulation code. So in this case, user can customize interface code from somewhere on the MCU, so it can decrease the cycle count and instruction count from baseline, and it can be much less when the extraction level is much getting higher. Then this this graph shows the increase of emulation time. We can I experiment for each model for TinyML, and it shows emulation time can be decreased from baseline that use every 4 cores of the interface. So in conclusion, I proposed sensor modeling and translator as to utilize modeling type development tiny model as an emulator-based approach. And this experiment result shows this approach can accelerate development using an emulator. Thanks for listening to my presentation.